Good morning, students. Welcome back to our discussion on the paper Object Oriented Concepts and Programming with C++. In today's class, we'll be learning about storage classes in C++. In our last class, we learned about what are reference variables. Reference variables are nothing but alternate name for the original variable, or they are also called as alias for the original variable. Where reference variables are useful and how to use reference variable. We also learned about the major difference between a pointer variable and a reference variable. A pointer variable and the original variable will have different address, whereas the original variable and the corresponding reference will have the same address, because a reference variable will points to the same memory location as that of the original variable. In today's class, we'll be learning about the different storage classes in C++ and also what is the purpose or what is the meaning of the term scope and longevity of a variable. At the end of today's class, you will be in a position to understand the different storage classes available in C++, the difference among the various storage classes, and the meaning and of the terms scope and longevity of a variable. Storage class indicate part of the program where the variable is accessible. Up to what part of the program the variable you have declared is accessible. Whether the variable is accessible only within a function, or whether a variable is accessible throughout the program. So that accessibility limitation is discussed or is defined with the help of storage classes. Any variable in C++, if we declare, the declared variable must belong to one of the four storage classes. The different storage classes available in C++ are auto, external, static, and register. So the variables that are used that you are using in your program must belong to one of these storage classes. So at the time of declaration only, you should specify the corresponding storage class of that particular variable. Let us start with the different storage classes. The first storage class is auto. Auto storage class is called as automatic storage classes. Here what happens is any variable which is declared inside a particular function belongs to auto storage classes. So a variable declared inside a particular function, we also know that it's a local variable. So local variable and automatic variables are one and the same. The main characteristics of an automatic variable is they are created when you call that function. When the moment you leave that function, the variable is destroyed. So the scope of automatic variable is restricted to only the function in which it is defined. So the automatic variable, you cannot take it outside a particular function. They have to be declared inside a function. They have to be used inside the function. At the time of leaving the function, the variable will be destroyed. And automatic variables are private to the function. Private and the local is one and the same. And for any variable, if you don't mention the storage class, it is considered as an automatic variable. So auto storage class is the default storage classes. As the name indicate, and I told earlier, the scope of an automatic variable is limited to the block in which it is declared. The block can be one of the function. So this simple program illustrates what are automatic variable, how to use them, and what is their scope. So in this example, I have declared inside the main function, I have declared two variables called A and B. So before the data type, I have not mentioned anything. In that case, A and B are considered as belongs to auto storage class. So the next line, the prototype void f, void indicate that there is a function called f that you are going to call it later, which does not take any argument because it is mentioned as void. And at the same time, the function is not returning any value. So return type is also void, and the argument place also I mentioned void. Now A equal to 10 and B equal to 20. So these two lines initialize the variable A and B with the values 10 and 20. First line, C out A, B, end line mean you display the value of A and B mean it will be 10 and 20. The output will be First line, it is 10 and 20. Next, you call the function called f. The control jumps to the function f. Inside the function f, I declare another variable called x, which is also integer type, but it is prefixed with auto mean. It is considered as an automatic variable. So in the first case, a and b are not declared with any storage class. Then also it is considered as an auto. And x is declared with auto mean. Here also it is considered as auto because auto is a default storage class. Now, the function inside the function f, I am altering, I am incrementing the value of x. It is permitted because x is declared inside the function f because f is a local variable. So x value becomes 5 and display the value of x. So x becomes, sorry, x after incrementing x becomes 6. Display the value of x means 6. So now you are leaving that function. At the time of leaving the function, x is destroyed because x is considered as a is declared as a auto variable. After coming out of the function, the control goes to this line a plus plus because a is a local variable means main function can access a. So a becomes 11 and b minus minus means b becomes 19. Again display the value of a and b means it will be 11 and 19. So in this example, you should observe two things. A and b are declared without any storage class. They are also considered as automatic variable. And x is declared with explicit storage class called auto. Then also it is considered as an automatic storage class. The next one is external. Any variable you declare it outside of all the function is considered as an external variable. Another name for external variable is global variable because the variable declared outside of every function is considered as a global variable. The main advantage or main characteristics of an external variable is those variables which are declared as a external variable, they are alive and active throughout the program, whereas an automatic variable is alive and active within that function because they are local to that function. And since they are considered a global variable, they must be declared outside the function. And another name for them is global variable. And generally, if you want to declare a variable with the storage class extern means you have to prefix with a word called extern. For automatic variable, the prefixing with auto is not compulsory. Here, x is a variable. It is declared outside of all the function means x is considered as a global variable. Inside the main function, the prototype void main void f void indicates that the function f takes no argument and not returns any value. Display the value of x because x is permitted. Because x is global variable means main function can access x. So x is displayed means x becomes 10. After that, you are calling the function called f. The control goes to f function. Inside that one, again x is assigned new value called 20. That is permitted because x is a global variable. Mean main also can access x and f also can access it. So x become now the current value of x become 20. You display the value of x means x becomes 20. After that, you come out of the function x plus plus. So still main can access x, but already the function f has changed the value of x to 20 means then the current value of x will be 20. Now x plus plus means x will be incremented. X becomes 21. It is right. So this is a major difference between an automatic variable and an external variable. Automatic variable is declared inside a function. External variable is declared outside of all the function. And automatic variable is alive and active only within that function. External variable is alive and active throughout the program. And only specific function can access automatic variable, whereas all function can access external variables. The third storage class is static variable. Static variables are declared using the keyword called static. The characteristics or the feature of a static variable is they are initialized only once. Even if you declare inside a function also, the initialization for static variable takes place only once. But the main thing is a static variable can be declared inside a function or can be declared outside a function. If you declare any static variable inside a function, it is considered as a local static variable. If you declare it outside a function, it is considered as a global static variable. And another characteristics of a static variable is even if you don't write it also, by default, static variable will have a value called 0. Right? Static int x. So I am not giving any value for x means still initial value of x will be 0. So this program illustrates how static variables are used. So int I. So since int I is not prefixed with any other storage class means The storage class for I will be auto. Void f. Next, for I equal to 1, I less than or equal to 3, I plus plus. When I equal to 1, you call a function called f. The control goes here, and here I declare another variable called x with initial value 0, and which is declared as static. So now what happens is this line we call it as a initialization line that takes place only once. Now x becomes x plus plus means x becomes 1, display the value of x 1. So already I told one characteristics of a static variable is they initialized only one and they retain their value before coming out of the function. It preserves the value. So x value is 1 means it is preserved. Next, I becomes 2, call again the function f. Comes here, this line is not executed. Previous value of x is 1. It will take it from that value. X becomes from 1, it becomes 2. Display it 2. 1, 2. Third time it call it displays 3. If you are not prefixed with a word called static mean, in that case, x is considered as a local variable. Then what happens is, each time when you call the function, it is created. First time when you call it, x becomes 0. X plus plus means x1, display value 1. But at the time of coming out of the function, x would have been destroyed in case if it is not static. But if it is declared as a static variable, means its previous value is preserved and initialization takes place only one. These are the two main characteristics of a static variable. The last type of storage class is register. The major difference is generally the variable are stored inside a memory location. But in some situation, we need to store certain variable instead of memory location. I want to store it in another type of storage place called register. A register and the memory locations are nothing but they are the storage places. And if any variable, if you want to store it in register, then you prefix the data type of that variable with register. The difference why we want to declare the register variable is generally your processor looks for the value of the variable first in the register. If the value of the variable is available in the register, immediately it goes there and fetch it. If it is not available in the register, means then it searches the memory location. So the accessibility is generally fast for register variable when compared to memory variable. So all auto, external, static variable are always considered as a memory variable because the variables, if you declare any variable with either auto storage class or external storage class or static storage class, in that case, the value of the variable is stored in memory location. But if you want to store the value of the variable particularly register, then prefix the data type with the word called register. So generally, register variable can be accessed fast. The question is, why can't we declare all the variables as register? No, that is not possible because every computer has only limited number of registers. Once all the registers are occupied, means that the remaining variable are automatically stored in memory locations only. So what you do is those data that you want to access it very, very frequently, such variable you store it in register. Remaining variable automatically you store it in memory location. Even if you declare 100 variable and your computer has only 5 register means, then only 5 variable will be stored in register. All the remaining 95 variable are automatically stored in memory locations only. So if you declare any variable of the register means register storage class means its time to access that variable is higher, fast. So this is how a register variable is declared. Register int x. So here the variable is x, and whenever CPU wants to access the variable x means it directly searches for the register because the variable is declared with the storage class register. Display the value of x. Otherwise, value-wise, content-wise, memory location, whether you store the data in memory location or the register, it's one and the same. The thing is, if you store it in register, the time to access the variable will be less. Next, we have to understand the two terms called scope of a variable and longevity of a variable. Scope of a variable determines up to what part of the program the variable is available for use. So it's nothing but another name is storage class only. And second one is longevity of a variable. Longevity of a variable refers to how long, till what time the variable retains the value during the execution of the program. Whether the value, suppose if you declare the variable as a automatic variable means it retains its value till you quit that function. On the moment you quit that function, value will be lost. So the longevity of an automatic variable is very short duration, whereas the longevity of an external variable is a lengthy. It retain its value for more duration because the value of the external variable must be there till you quit the program. Scope refers to till what part of the program the variable is accessible or available for you. Again, here also same thing. If you declare any variable as an external variable, means it is available and accessible in the entire program. But any variable is declared as an automatic variable, means it is available only for the function inside which it is declared. But scope of a variable and the longevity of a variable is very, very important concept with respect to a program. So some of the review questions are: explain the different storage classes with example, compare auto and external variable, write a note on register variable, and define the term scope and longevity of a variable. Scope means how long the variable has its utility, availability. Let us take some simple multiple choice questions on today's class. Dash is also known as a local variable. Generally, automatic variable is considered as a local variable. The correct answer is B. Dash retain its value during successive function call. Only static variable can retain the value. The correct answer is D. Dash is the widest scope. It can be used for more part, larger part of the program. It is global. Frequently accessed variable are declared with dash storage class. It is register. So here the correct answer is D. And the default value of static variable, I told earlier, if any variable, if you declare any variable with the storage class static, and even if you don't give any initial value also, by default it is takes the initial value as 0. The correct answer is B. Students, in today's class, we learned about the concept of what are storage classes. Once you declare a variable, it will be stored somewhere. And to what is its category? The category is called as storage classes. We also learned about the different storage classes in C++ like auto, external, static, register. And what is the difference between auto, external, static, and register variable? Because the first three, they are memory variable, and register is a different place. And register variable, the access time is very, very less when compared to memory variable. We also learned about the term scope and longevity of a variable. So with this one, I'm going to conclude today's class. Thank you.